Now we are ready to talk about another example for application of expectation maximization for NLP task. And the NLP task today is this weekly supervised question answering. And we use the hard version of that because expectation maximization, you could implement it as a soft approach or hard approach. And a latent variable are discrete. For example, Z1, Z, so they are discrete in nature. And the reason that I really like Allen Institute is because of great researchers like Hanane Hajishurizi, and so they are concentrating on using NLP for future products such as chatbots for mental health, chatbots for hiring, anything. So they are deeply focused on these NLP. That's why it's a really interesting institute, this Allen Institute in Seattle. So let's first appreciate the beauty of weak supervision, because sometimes you don't have full supervision, you have weak supervision. And what do I mean by that? For example, in Trivia QA dataset, which is a dataset for multi-mention reading comprehension, you have a question, but your answer is just for example, this start span, end span, this is start span, this end span. So you see, this is repeated at different parts of this text or document. But you should know which part of this document can be the real meaning or semantic meaning of this question. Because, for example, marrying is related to the husband, and this sentence has a better interpretation. So, and also it also shows that your chatbot is not imitating, it's not memorizing. It is understanding, which is a higher level of consciousness. Another example is the drop dataset, which is really interesting because you know that the answer is 4, but is it 41 minus 37 in this or different combination of that? So you should see how the robot has done the reasoning, and in order to make sure that it is not imitating that, it is understanding that, it is interpretable, and it is explainable. So there are 6 QA datasets, four of them because Trivia QA, there is another version of that which is for open, and also we have drop, which is reading comprehension with discrete reasoning, and also for semantic parsing. I will explain another playlist for semantic parsing. I've explained semantic parsing in conversational AI playlist, but I think I should create another playlist to make it separate from others, to have because I want my playlist to be very coherent. A discourse that is really coherent so that people can focus on that with minimal prerequisite, minimal dependencies with other playlists. And so at inference time, at inference time, we usually can approximate Z of total, because Z of total is just all of the spans. For example, here, starting from this, ending from this, starting from this, ending from this. So you see there are so many spans, and of course, it covers the spans for the actual answer. But we want to know so Z of total is a very big space, Z of total. But some of them, so Z space, which is subset of that, this subset, which is, so for f of Z is equal to Y for this subset, and Y the real answer. So all of these points inside this are candidates, and one of them is the best candidate. So we call it best span, best start and end of the span. So by enumerating all of them, this results a set of all possible solutions. So the learning method is like this. In our weak supervision scenario, the model has access to X and Z, and a selection of the best solutions, Z of best, as I said, can be modeled as a latent variable. So we can compute the maximum marginal likelihood, which marginalizes the likelihood. So one kind of that is, because Z of total, as I said, we only care about the one that are inside Z, the subset that the answer is inside the span, although it may or may not be the best solution. And their target and their objective is just the minus log likelihood of the latent variable given your sentence and parameters that we should learn. So a variant of MML, as I said, is like this. Is we just replacing sum with maximum. So this is a sum, but here we just use the argmax of that, and after calculating Z tilde, the objective can be written as probability minus log probability of this argmax given X. So this is a kind of expectation step, because we only care about the latent variable. But this is the maximization step, and so this is the multi-mention reading comprehension example. So we have a question, some tokens for the question. We have some tokens for the document. It could be very large. And then we have this definition. I mean, G is just binary. It could be 1 or 0. We just want to make sure it knows the span. And the example for multi-mention reading comprehension, as I said, Robert Schumann is the answer, but we don't know the span, if it is from here to here, or if it is from here to here that has the best meaning. So as I said, Z of total is all spans, but Z is just a subset of that, which matches that. And from Z, there is just one point. There are so many points here, but there is just one point that has the best answer. And of course, we implemented with BERT because it is pre-tuned, and we can use this representation of the sentence, and then we give it we know the output because we know the start and span, the end of that span, and that's why we have this probability. Because they are independent, we multiply them, and so we get the probability of your latent variable. We have calculated the hard way of expectation. We have calculated. There's no, for example, K-means is a soft way of implementation of these latent variable models. And W1 and W2 are the ways that we should learn. Another category is when we want to use the dataset for drop, which is for discrete reasoning. The same way, here the same intuition. And finally, the SQL Query Generation. Now we are talking about semantic parsing. An example is that, for example, H could be head and tail, could be position. This is head. The tail could be the guard. And if position equals to guard, it has something that the database can understand when you want to query. So in SQL, when you the chatbot wants to convert the meaning, to understand the meaning of that, it should convert to something like a SQL query so that it understands this text or what your question is. Sorry for breaking the silence. We are using the separate token because we want to make sure that this model understands that question is separated from the paragraph. And also, we want to teach it by start and end span because we know the actual start and end span for the training data, but for the inference, we will get it at the inference.